Alright, so now we get back to something we have done before. Woohoo! And we're going to show how a difference formula, and we can prove our cofunction identity. So what we're going to do is we're going to use, instead of just showing that the sine of x minus pi over 2 is equal to negative cosine of x and just taking it for granted, what we're going to do is we're going to say this is the same thing as having a sine of u minus v. So in this case, your x would be a v. I can't even talk. X would be your u. Everywhere you have a v, you're going to plug in a pi over 2. So if we use the formula for the sine of u minus v, then that formula is your sine of u times your cosine of v minus cosine of u times your sine of v. So everywhere we have a u, we're going to plug in the x. Everywhere we have a v, we're going to plug in pi over 2. So we're going to say the sine of x times the cosine of pi over 2 minus the cosine of x times the sine of pi over 2. So we just have to evaluate where we have our pi over 2's. We're going to say, well, the sine of x times your cosine of pi over 2 is just 0. Minus your cosine of x times your sine of pi over 2 is 1. So if we simplify this, sine of x times 0, that's just gone. That's just 0. It's out of there, folks. What you have left over is a negative cosine of x. So what we did is we just plugged in x for our u and pi over 2 for our v, used our sum formula, and showed that this was all equal to a negative cosine of x. So yes, finally, that stuff we learned in 5.1 and 5.2 did come in handy. Way to prove this cofunction identity, folks. Who's the bomb?